This video corresponds to one of the problems that's on the slides that I handed out as part of class. The numbers here are slightly different. So as we saw in class, what we saw with the slides, that it's easy just to make a guess for the answer. The question is how much was loaned at 9%. So of the $14,000, I could guess maybe, I'll just make a wild guess and say I'm going to guess that $10,000 was loaned at 9%. Let's bring that sign. In order to check that, I would have to, if this I'd figure out the interest that's paid. So if this $10,000 was loaned out at 9%, then the interest received would be 9% of 10,000. So that's 0.09 times 10,000, which is $900. Now the remaining, that's $10,000 that was loaned at 9%. The remaining $4,000 was loaned at 17%. So 17% of $4,000 would be the other way that I'm getting interest. And so 0.17 times 4,000 is 680. And so the total amount of interest that I'm getting is 900 plus 680, which is $1,580. Now the goal, remember, was, we know that what's really supposed to happen is that $2,000 was received in interest. So this value here is not 2,000, and so therefore this guess, the original guess here, is wrong. But the reason for going through the guess process is that now I have some idea of how to set up the problem using the letter x. So instead of saying, let's just guess a number, I'm going to say, let x be the dollars, not just write shorthand here, dollars loaned at 9%. And so this calculation that we did to check here tells us everything we need to know about how to get the total interest. Notice part of this calculation was figuring out that there were $4,000 invested at the other rate. So that $4,000 came from subtracting $10,000 from the total of $14,000. So I know that if x is how much was loaned at 9%, then $14,000 minus x is the number of dollars loaned, if I can write that, loaned at 17%. So I now have these two quantities written in terms of x. Instead of being specific numbers 10,000 and 4,000, they are x and 14,000 minus x. So now the rest of this calculation is the same. The total interest that's received is 9% of x. So instead of 9% of 10,000, I have 9% of the amount loaned at 9% plus 17% of the other amount, 14,000 minus x. And I know that when I do that calculation, I don't want it to add up to 1,580. I want it to add up to 2,000. That's what it says in the problem. So notice that here I'm doing all these calculations with numbers. Over here I'm doing exactly the same logic, but I'm using the letters. So my equation then is just 0.09 times x plus 0.17 times 14,000 minus x equals 2,000. And I have to solve that for x. And so to do that, I'm going to first multiply this out. This is unsimplified over here. So I need a calculator to figure out that 0.17 times 14,000 is 2,380. course, 0.17 times minus x is just minus 0.17x. So I'll combine these two terms that have x's in them. 0.09 minus 0.17 is negative 0.08x. And over here I'll have 2,000 minus 2,380, so negative 380 when I put my non-x terms on the other side. So if I do that that division, I'll divide both sides by 0.08, and I get 4,750 for x. And so that's the number of dollars, again, that are loaned at 9%, which means that the balance, which would be $9,250, is invested at 17%. But the answer to the problem, the number that goes there should be 4,750.